Fused Deposition Modeling. The video introduces the Fused Deposition Modeling, which is one of the most common additive manufacturing methods. In the first step, the building material is mounted on the 3D printer. A spool of thermoplastic filament with a diameter of 1.65 mm is fed into the heated extrusion head, also known as print head. The material load is follows. The 3D printer starts winding the thermoplastic filament into the print head. Some of the material is extruded through the nozzle so that the material residues from the previous print are also extruded out. In the next step, the software for the process of fused deposition modeling is open. The appropriate 3D printer for additive manufacturing is selected, and the relevant file for the model of the tube is imported. The setup of parameters of the imported model follow. Based on the shape of the part, the software automatically rotates the part to the appropriate orientation with respect to the build platform. However, this position can be changed by the software operator. The position of the part is also determined automatically by the software, but can be changed if necessary. This feature is especially useful when printing multiple pieces at once. It is also possible the model resizing continuously with a computer mouse or by entering a specific value for the individual axis XYZ. If necessary, the model can also be splitted by selecting the required plane and defining the position of the plane with respect to the coordinate system. In the next step, the production parameters are set, such as material, layer thickness, nozzle diameter, printing speed, extruder flow ratio, extrusion temperature, temperature of build platform, type, pattern and density of infill, offset for outer contours and holes. The steps are followed by material selection. If necessary, support structures can be set. In our case, the support structures were not adjusted because the shape characteristics of the model didn't require it. After setting the production parameters, the simulation of the manufacturing of the part in the given software follows. In this phase of the simulation, the model is sliced into layers. This is necessary to generate paths for the print head for manufacturing the model layer by layer. The estimated print time is 1 hour 42 minutes. The material usage is calculated for 14 grams. The filament is made of acrylonitrile butadiene styrene, abbreviated as ABS. The nozzle diameter is 0.4 mm, the layer thickness is 0.19 mm, and the infill's value is 60%. After simulating the manufacturing process in the software, the program is exported to the memory card. The process is continued with the insert of the memory card into the control unit of the 3D printer. After inserting the memory card from the menu of the additive manufacturing device, the file is selected and the additive manufacturing process starts. Prior to production, the build platform must be warmed up to the desired temperature, which in our case is 80 degrees Celsius. when the desired temperature for printed and build platform is reached, the additive manufacturing process begins. On the accelerated video is the layer by layer manufacturing process, while the actual production time is 1 hour 48 minutes. After the production process is completed, the part is mechanically removed from the build platform using a spatula scraper. The next step is the post-processing. In this case, it consists in removing the raft manually or also using a spatula scraper. The next step of post-processing is the finishing of the 3D printed model manually by abrasive paper, which rounds sharp edges and reduces the surface roughness. The last step of post-processing is the modification of the 3D printed model using a liquid solvent, application which results lower value of surface roughness. The model of tube part manufactured by Fused Deposition Modeling method is finished. So I have two questions. The first question is, what do you think? Why is the method of additive manufacturing Fused Deposition Modeling is one of the most widespread?
It's very cheap.
Exactly, it's very cheap. And what is cheap, the device or the material?
Both.
Both of them.
Both of them, exactly. And what do you think? What is the price of one spool of ABS material? It's about 1 kilogram. The weight is about 1 kilogram. What's the price? What do you think?
Around 500 or 1,000 euros.
Do you think
if we talk about the machine?
You talk about the machine, yes, it's correct. So it's about 500 euros, okay, but also it's possible to buy about 300 euros. Okay, so thank you very much for the answers. And what's about the price for the material, the spool?
Around 15 euros.
Okay, 15 euros, okay, exactly. It's true also, but of course, you can buy also for 60 euro or 70 euro. It's about the quality, but for many times the spool, which weighs approximately 1 kilogram, boxed for 15 euros is also enough for many applications. Okay, the second question, what are the advantages and disadvantages of this method of fused deposition modeling, of course?
Well, the main disadvantage is probably the time spent on the creation of the manufacturing of the part alone.
Yes, it's. You think it's an advantage or disadvantage of this method? Disadvantage. Exactly. This method is really slow in comparing with another additive manufacturing methods, correct? And some advantage or advantages, what do you think?
I think there is no limitation in the shape of the model.
It's true. Yes, many times the additive manufacturing technologies are able to manufacture very complex geometrical shapes, also free from surfaces. So yes, it's true also. Some limitations exist, but almost every shape is manufacturable with this method. Okay, thank you very much for your answers.